I'm Stephane. I was previously co-founder and chief architect at Flashbots, where I built something called the MEV supply chain and all the jazz that comes with it. Now I lead a research team called Frontier Research, and then I'll be joined with Ankit to talk about chain abstraction. It's a topic that we've been diving into for a few months now, quite in depth, but something that's been a passion of mine for many, many years. So I'll talk a little bit more about that, if I can get the clicker to go. So my journey with chain abstraction started in 2019. I built what I claim to be, maybe it's not, but it's my claim, to be the first chain abstracted application on top of Ethereum. So it had basically no signs that you were using a blockchain, despite you using Ethereum behind the scenes. It was social login, and all the interactions were basically using USD. And it was beautiful. It took me a really long time to build it. I really cared about it, and it had 0 users, and it was really sad. But it was a really cool experience to build. I was really impressed with the usability that was possible to achieve on Ethereum at that time. But what happened was gas fees went like this, and then usage went like that, and then we realized, oh wow, it's really impossible to build anything that's Web3 on Ethereum without Ethereum scaling first. So between 2019 and now, basically, it's been somewhat useless to build anything Web3 related. And we've ended up in this situation, where on Ethereum, if you want to build anything, getting a transaction on-chain goes through an entire mess of different actors. And so somehow, we have all these different other layers now, roll-ups, that allow us to have scalability of block space. But we've lost the usability of the blockchain. And we've gotten into a scenario where users have to manage balances across 10 different networks in order to get something done. So we've flipped from usability to scalability. And basically my claim is that with chain abstraction, we can build new types of apps that actually achieve both on top of Ethereum. And that will happen this year. So we introduced what we call the Web3 cake, or chain abstraction key elements. You might see this online. We have nice merch over there and a nice cake that you can taste. But we presented this framework as an approach to building these applications in a way that you leverage all the middleware that's been developed in the past few years, all the improvements over block space scalability, while still having and providing a great user experience to the users that are using the application, and a good developer experience. So we launched a working group with a bunch of different parties in the space. Near Agoric are helping host this, that we call the Chain Abstraction Working Group, or the Cake Working Group. And we're hosting a workshop tomorrow, as well as one in London for ETHDenver. And we will aim to further the cause of chain abstraction across the entire industry. All right, if we are successful, it'll look something like this. So just like Web2 had its own layers, Web3 will have its own layers as well. And quickly we will realize that as we get baking, the cake is the last stage of the process of Web3. I personally think it's the most interesting and exciting time to be building in Web3. Like, now that we have the scalability and we have the middleware tooling to be able to build solid applications, we will see a huge explosion of different applications being developed by developers that are coming from the Web2 space to build with us. We can only see where this will go. So I will pass this over to Ankit now to go a little bit more in depth about the cake.
So let's first dive deep into figuring out what exactly is chain abstraction, what we mean by chain abstraction, why is it needed, and then we look at what are some type of products that people are building explicitly and implicitly currently, and how they fit together, how they compose together. And so let's go back 20 years when the Web2 revolution was happening. Suppose you wanted to send an email from Gmail to iCloud, and you had this PDF, like wedding invitation, and no SMTP, no HTTP, no standardization of how these different layers communicate with each other was happening. What you would do is you would go to an email aggregator, you would somehow enter the to and from address, you would paste the PDF, and then you would get a bunch of options on how do you send that email from one person to another. And once you do that, basically, once you sacrifice tens of minutes and tens of dollars, you would get a wrapped version of PDF. You won't even get the original version of PDF. You get the data missing somehow. And so this is a very broken experience. Thankfully, that is not the case. So thankfully, that is not the case. Instead of doing this, wasting tens of minutes and wasting tens of dollars, what you have is a very clean, very sophisticated drag, drop, and send type of experience. And this is what chain abstraction delivers, basically. Unfortunately, that is not the case in crypto today. Like, this is what we have. And so you have 10 different rollups. You need to save balances in each of them to pay for fees. Every 10 seconds you need to do this confirmation to switch networks, and then you have these aggregators where you need to somehow bridge to actually do what you want to do. And so if you want to give this kind of experience to Web2, if you want to build the next set of applications, you need to abstract this all away from the user. And it's our opinion that block space is abundant by now, and UX is the bottleneck to build the next set of applications and to bring the next 1 million set of users. So the ideal user flow should look something like the user just connects their wallet to a tap, signs what they want to do, and then just wait for it to happen. Everything in between is just abstracted away from them, and that is how you get the next billion users involved. So, Stephane told you about these different layers of cake. Let's look at what are the design trade-offs in each of these layers of cake and how all they compose together. And if you are building like a chain abstraction infrastructure, what are the trade-offs that you need to make to actually build a successful product? So, the first thing that you need to do is decide what type of message you are transferring across chains. So, are you transferring a normal message like information, or are you transferring value? So a normal message, all types of messages, they need to be lossless. And so if you are participating in a governance vote and you want to vote yes into that governance vote, you don't want that information to be converted into a maybe. And so it has to be lossless, and henceforth it needs to use all the secure pathways that are. And some examples are like governance voting approvals for message transfers. The second type of transfer that blockchains are meant to do are value transfers, and this is what blockchains are made for. So when you transfer value from one place to another, it has to be scarce. You need to maintain the scarcity. You need to maintain the atomicity of that transaction. And what you need to do is basically, if you're sending from one person to another, you need to deduct balance from the first person and credit in the second. And it can be lossy. Like you can bring in third parties and say, okay, like if I'm sending $100, I am willing to take a loss of $1 and just receive 99 on the other end. And so you can bring in these sophisticated third parties which give you a better UX. And 95 to 99% of transactions today on blockchains are value transfer. They're like transfers, swaps, payment for gas. All these are types of value transfers. The next set of decisions that you would need to make are in these different layers of the cake. And so when you are talking about the permission layer, the core trade-off over there is between UX versus agency. So where in the spectrum of UX versus agency does the user fall? If the user wants to have all the control, then they would prefer something like an EOA wallet. But if they want better UX, they would switch to they would give control to the user or the solver in between. So you have things like account abstraction or policy-based wallets, which are Telegram bots or what Neil is building, are examples of these permission layer infrastructure options, which basically give more UX improvement to the user. The second thing that you would want to do is, on the solver layer, is figure out this trade-off between optimal routing, which is finding the best path to make sure that the user's transaction gets executed, versus actually making sure that the transaction gets executed. So imagine in a cross-chain world where a transaction needs to take 30 hops to actually satisfy what the user wants to do. There are many failure cases in between. And there are multiple possibilities of actually making sure that the transaction gets executed. And so if you want to find the best price, if you want to find the best route, what you would do is you would bring in a lot of solvers. You would say, hey, give me the best price, compete against each other. But if you do that, then other solvers can front run that transaction and reduce execution guarantee. And so you need to do this trade-off between how much information I should reveal to resolve this trade-off. The third trade-off is in the settlement layer, which is between low fees and execution speed. And so when you are trying to settle these transactions, you need to somehow communicate between these two chains, and you will need to wait for finality. If the finality is on Bitcoin, you would need to wait a certain number of blocks, and that can take something like an hour. And so there is this, if you want low fees, you would basically use the ecosystem aligned finality. But if you are okay with, if you want better speed, then you can bring in more solvers. You can bring in, okay, the solvers will take on some finality risk and give you what you want at a better speed, basically. So these are the 4 trade-offs that you need to take into account if you're building like a cross-chain abstraction framework. What you want to transfer, is it value or message? How much comfortable your user is? And do you want to basically optimize on execution speed, execution guarantee, or fees? So that's what brings us to basically the cross-chain trilemma. So there's this trilemma between these 3 things: execution guarantee, low fees, and execution speed. And depending on what you try to optimize for, you would fall into one of these 3 categories. And depending on how comfortable you're using users, you would go more into this direction of this trilemma, basically. And looking at these 4 trade-offs that an application needs to make, and this cross-chain trilemma, you get 6 pieces of cake, or 6 different designs that basically emerge, where the user can choose whatever they want depending on what they prefer. And these 6 different designs compose very nicely with each other, and they have their own product market fit. So suppose if you want to do a value transfer and you want to sacrifice for speed but have very high execution guarantee and pay very low fees, what you would do is you would use a token anointed bridge. So something like USD where what happens is the token team basically says, okay, this is the canonical token address on each of these chains, and this is the canonical bridge on each of these chains which can mint tokens on the target chain. And so this is how you have token anointed bridge. It has to wait for finality on all the chains where it is transferring value, but because it is anointed by the bridge, there is very little fees. The second thing that you would do, if you want to transfer a message and not value, is you would use an ecosystem aligned bridge. So this is like a shelling point in an ecosystem where the ecosystem appoints some sort of a bridge which is used to transfer arbitrary messages across the ecosystem. So these are things like IBC, Adler, Superchain, where these are ecosystem aligned message pathways to transfer messages across different parts of the chain. The second type of chain abstracted products that you can build are called as solver competitions. So if you want to get a good price, if you want to find the optimal route, what you would do is you would let solvers compete with each other. And so the first type is if you want to transfer value or if you want to do swaps, you would make solvers compete for price amongst each other. And so these are things like Jumper, Bungee, UniswapX, where there are a bunch of solvers. These look like aggregators and a bunch of solvers. They give them some code, and based on the best price, the user gets what it is. On the message transfer side, you have these wallet coordinated messaging systems. So things like Alfred, Avocado, Near, where the wallet acts like a super app. So the wallet is an aggregator of an aggregator. If this was an aggregator, the wallet is an aggregator of an aggregator, and it can pick and choose whatever the user wants and executes it. On the third is this execution competition, where you sacrifice on basically price improvement or optimal price, but you are trying to optimize for execution guarantee. So you are trying to optimize for if I can actually make sure that my transaction goes through, if I can actually make sure that of those 30 things that I need to do to actually satisfy user's intent, they actually end up happening. And so you get things like solver speed competition, where solvers are competing not on price, but on speed, whoever gets to execute that intent first. And then finally, To transfer messages, you have things like PFOF or Robinhood, where there's no competition between solvers. You just give whole flow to the solver, one single solver. There's no information leak, and then they can batch things together and make sure that the users are satisfied at a high execution rate. And so these are the 6 pieces of cake. To just recap, I think chain abstraction ideology is the ideology that users should not care what network they are on. Users caring what network they are on in Web3 is very similar to users caring on the internet era what cloud providers they are on. So like AWS or GCP, they don't care about that. And we introduced the cake framework to think about these chain abstraction key elements and how they compose with each other, how these different layers compose with each other, and what are the design trade-offs, and what are the 6 designs that emerge. And I think in order to successfully make the leap of chain abstraction, let developers build the next set of application, bring the next magnitude of users of crypto, we need some sort of standardization on how these different layers of cake communicate to each other, and that is in the case. Thanks a lot.